Oh, hey, it's Dr. J. I'm back. One more quick example. This is a question similar to the last one, but it's sort of reversed, but the same kind of concept. We want to find the equation slope-intercept form of the line shown. So I give you the line, you give me the equation. The problem with this one, the key problem, is that we can't see the b. I sometimes refer to b as a freebie, but not today, because if you can't see it, then you have to find it. And you're going to find it algebraically by first finding m. So first find the slope. You probably have this formula memorized by now. I certainly hope so. y2 minus y1 over x2 minus x1. And you get to choose which 2 points. And you can choose literally any 2 points on the graph. So come over here to the graph. And I hope my cursor shows up nicely. Let's see if this time it does. Yes, you can see my cursor. Sometimes my cursor seems to disappear and I can see it, but you can't. So come over here and very carefully choose 2 nice points. Pay very close attention to the scale in this particular problem. So 2 blocks is 1 unit, right? So 2 blocks is 1 unit. So I don't want to go here. The x-intercept is not very useful. It's negative 2.5. I'm not saying you can't use negative 2.5, but why would you if you can avoid it, right? So let's go to a nice point. How about right here? This looks like a nice one. X is negative 3 and y is 2. So I will call that my first point. X is negative 3 and y is 2. Since that was the first point I chose, I'm going to call that x1 and y1. The subscripts are your choice, which one you want to label x1 and y1, but you should be consistent. So, once I make that choice, I don't want to change my mind halfway through the problem. I also don't want to mix pairs. So I wouldn't want to pick an x from one point and then a y from another. I know it seems like a silly thing to warn you about, but I've seen it all before. So come back over here to the graph and choose another point. You probably could find one as I'm talking. Positives are okay. You could do down here, they'd both be negative, but try to find a good one that doesn't have any fractions. So how about right here? Negative 4 for x and 6 for y. That looks good to me. So negative 4 and 6. That was my second choice. So that's going to be x2 and y2. You can literally choose any pair and you can label them any way you like. X's and Y's must be in that order, but as long as they're in the right order, it doesn't matter which one you say is X1 and Y1. Now, let's go ahead and find the slope now. I already had the formula up there, so we're going to do Y2 minus Y1 over X2. That's Y2 and Y1 over X2 and X1. Now I should be really careful with negatives. So x2 is negative 4. x1 is negative 3. You've heard me say this before. Be careful with negatives. I wasn't very careful in the numerator because it's just 6 minus 2. I mean, I'm as careful as subtracting needs to be. But here in the denominator, I should be very careful. That's going to be negative 4 plus 3, so the denominator is going to be negative 1. Now, you could leave this as a fraction. I don't think it would mark it wrong. I certainly wouldn't. But I would just prefer you clean up the mess a little bit and just make it negative 4. All right. If the slope comes out to be an integer or a whole number, No fraction. There's no need to keep it as a fraction. Although it is sometimes to your advantage to think about it as a fraction. So maybe I'll put my little cloud here that I love. It basically means that if you look at the graph, it's going up from one point to the next. It's going up 4 units. Yeah, see? And it's going left. So it's a way of thinking about slope, sort of a left-oriented direction. So moving according to your left hand. So when you think about the slope, it should match the points that you actually chose. All right, well, that's the first step to finding B, is to first find M, which gives you kind of half the answer here. All right, and now we're going to use the point slope formula. So we've got y minus y1 equals mx minus x1. Now, since I already made my choice of x1 and y1, I'm just going to be consistent and stick with it. All right. Now, I could choose the other pair. All right. There's no law preventing me from choosing x2 and y2. Right. This formula is equivalent to this formula. Although I've never put it this way in one of my lectures. And, when I was a student, I didn't memorize this one, but I did, at least at some point, understand the concept that it doesn't really matter which pair you pick. All right. So I'm going to go ahead and stick with my original choice. So I've got y minus 2 equals m. I know m now is -4. Being extra careful with double negatives, that's going to be x minus -3. You could just change that to +3 now. I'm going to do that first. So that double negative here changes to positive. All right. And then the next step would be to get rid of the -4, or not get rid of it, but distribute it. So you have -4x plus -12. I'm not going to write plus -12. I'm just going to write -12. Technically, that's plus a -12 if we were writing it in its unsimplified form, but I like to simplify. Finally, we're one step away from the answer. We just add 2 to both sides. And you should get the final answer in this step. Y equals -4x minus 10. Which confirms why we couldn't see it on the screen. This grid doesn't go down to -10 on the y-axis. It only goes down, it looks like -8. So moving over to my text box here, I'm going to type in y equals -4x minus 10 on the pop-up menu. I don't really need it. Just ignore it. And go ahead and submit that. And it's all green. All good. All right, I hope that was helpful. This type of question pops up from time to time where it just kind of, doesn't exactly match the way that you've seen it before. So I try to address those whenever possible. So keep the comments, the questions, the feedback coming, and I will keep making these videos for you. Stay tuned for the next full long lecture on applications of linear equations, where we'll actually see how these equations can help us in the real world. But until then, I'm Dr. Jordan, and I'll see you on the internet.